Welcome to the presentation on testing with dependencies. In previous presentations, we talked about unit testing and the benefits of automated testing. But when it comes to writing automated tests, dependencies often cause some challenges. When it comes to dependencies, it makes really hard to test, and oftentimes we tend to give up on testing or not effectively test. So in this series of presentation, we'll talk about how to really write automated tests when we do have dependencies. The answers to some of these questions may surprise you. The answer is simply not to mock away, but to do so in a very selective manner. Let me start out by first saying, the more mocks we use, the poorer the design actually is. So I use mocks, but I use mocks very selectively. I use mocks more than as an exception than a norm. So I will talk about quite a number of those things and then talk about how to effectively use mock objects as well. So let's get started. The benefits of unit testing and automated testing is overwhelming in a number of different ways. Once we start using it, we see several benefits of it. The first benefit, of course, is regression. We get real good confidence that code that worked yesterday continues to work today as we evolve the application. And we cannot take that very lightly. Test-driven development also has design benefits, as we talked about previously in other presentations. It serves as a safety net when it comes to refactoring. It is a form of documentation for us to look at how a code is being used and what its behavior is. It gives us an ability for us to make the code modular. It really gives an early warning sign when the code is not cohesive or fails on a single level of abstraction principle or single responsibility principle. So there are several benefits if we apply TDD properly. Well, TDD and automated testing and unit testing is extremely easy. Well, it is easy if, and there's always that if. Well, it is very easy if the code we are trying to test has no dependencies. Look at this particular example of a few different classes. Now the class on the left depends on these two classes, and these two classes in turn depend on this class. Now unit testing this class is extremely easy, because it doesn't have any dependencies. We can put this on the table and start writing test on it, or we can write test and write code. And so as a result, it's very easy to start expressing these test cases from the get-go. So that is pretty simple to write unit test on code which has no dependencies. So when there are no dependencies, nothing really stops us from writing these test cases. But unit testing is relatively hard, unfortunately, when the code we are trying to test has dependencies, like this one. It is extremely hard to write test on these, or could turn out to be really hard. For example, this may depend on a piece of code which is extremely difficult to set up. Maybe the setup is so laborious that we give up on testing this code and we just simply say, let's just do it in integration, maybe manual testing. Or the code it depends on maybe is very unpredictable. It's really hard to know what kind of response it's going to return. For example, what if our code makes decision based on the current weather? Well, how do you tell what the current weather is? And every time you ask for the weather keeps changing. And every time during the day, it may be sunny, it may be cloudy, it may be snowing all of a sudden. It depends on where you are, but oftentimes the weather fluctuates very quickly. So is with room temperatures and pressures, for example, depending on where you are. And if you are writing this in a flight, for example, the conditions quite change depending on the altitude and other conditions. So how do you write a test on a piece of code that in turn depends on something that is very dynamic and unpredictable? So oftentimes we tend to give up on these things. Well, remember, automation is extremely important for us to maintain and sustain agility. So automated testing, to me, testing means automated testing, except in places where we do manual exploration testing. Or use the word verification, I want automated verification all the time. So how do we really get automation verification if we have code that has all these dependencies? How do we proceed with it? It becomes very intimidating, and even writing the code becomes really hard when we have all these dependencies. For example, in one of the applications I was developing, I have to constantly go to the cloud and get some data from the cloud or update some data on the cloud. Likewise, I have to integrate with credit processing system. So I have to charge credit cards or validate credit cards and what have you. and I got to talk to an inventory system or an accounting system. And how do I write code that has all these different dependencies? Could it not become really hard to write and automate these test cases? Well, there are some techniques we can use to clearly make our lives a lot easier, and we're going to discuss some of those techniques in this presentation and a couple of presentations that follows this. So before we even go further, there are a couple of things we can do to make our lives a lot simpler. For example, let's talk about how do we really create a system from the point of view of testability. Now take an example of credit card processing. Credit card processing is a very touchy subject. You could offend people and you can call them names, but you can never make them as angry as messing with their finance. So the point really is you cannot really overcharge or wrongly charge people, or end up really coding one amount and charging something else, or charging people a couple of different times for the same transaction. I sometimes go to international websites, I go and try to purchase a ticket, and by the time I click on the credit card payment, it ends up with a blank window. What gives? How do I work with it now? Did they charge my credit card? Did they, more important, purchase my ticket for me? And I go to my bank to see if the credit card was charged. And sometimes I don't see any charges. Sometimes I see multiple charges. And then you are trying to get on the phone. And usually this company doesn't have a good phone connection to call into. Hours wasted trying as a customer to deal with it. Well, where does the problem really start? How did they really do the testing to deal with this properly? Now, here's one of the beauties of credit processing. Most of the credit card processing systems actually give us two different keys. A key is what ties your transaction to your business. So if your company, XYZ Corporation, wants to charge credit card, there is a secret key that's provided to your company. And so when a transaction is performed using that key, any particular transaction that happens on the credit card gets credited to your company's account. However, most credit card companies also provide another set of keys which are called test keys. Anytime you use test keys, the requests don't go to the main production server. Instead, they are directed to a proxy server. The proxy server will receive your credit card information, do the processing, but it's all faked up. It doesn't really give you a real result back to you. And when the response comes back to you, you can take actions based on it. So for example, the credit card number 424242, keep going up to 16 digits, 4 twos, and that is an example of a valid test credit card number. Now don't try this on a site and see if it works, but that's the credit card number we use for testing purposes. If you use that with a production key, that would fail, but if you use it with a test key, it indicates a proper credit card number. So you can run your test by running your automated test, and when it comes time to charge a credit card, you provide that number, and the service that provides the fake response, the proxy, gives you a response saying, yep, the credit card was charged, and makes a real good transaction like the way a real transaction would look like. So now on your code side, you can receive the transaction detail, do whatever you want to do with it, log it, create a receipt for the customers, email the customers saying that the transaction went through. Of course, during the test phase, the email will be sent to a test account, or you can fake that away also, as you normally do. But the point is, you have tested this thoroughly automated manner. There is also a credit card number 4242 all the way up to the last digit being a 1, and that is a credit card which is considered to be invalid. That's a one that could be expired, for example. So you could write another test case where you give that fake credit card number and the test ID, the test key. And of course, the proxy server for the credit card company will now return an error code, and you can make sure the error code you received is the error code your code actually expects. And then you can take the necessary action, like for example, creating a log for the failure, notifying the customer appropriately, sending emails, doing proper logins in various areas, and doing other accounting, and making sure that the purchase does not go through and you don't update your inventory, or you don't provide access to the customer that they were trying to purchase. Now, look at the beauty of this. Using all of these conditions, a valid credit card, invalid credit card, expired credit card, one that has been overcharged and out of credit limit, and one that is providing a wrong CVS number, or the one that has a poor, bad expiration date being entered by mistake. All of these situations you can thoroughly automate and test with full integration to a credit card processor. Thankfully, because the credit processor provides a proxy service and they route you to the real service or the proxy service depending on the test key you provide. This approach is called using a fake. So a fake really is you talk to a service, to an object, to a class, to an instance, whatever that you talk to it like you talk to a real one. But the faked out service would be faking out responses back to you, and you don't have to change anything in your code. Your code has no clue whether it's talking to the real service or the fake service. So depending on the test key versus real key, you could configure this. So when you start designing your software systems, think about designing from the testability point of view. How would you create your application so you can make testing trivial, make testing easy, make testing simple? That is something for us to keep in mind. If testing is really hard, the feedback loop is really not available, and that increases the risk of the development. So start by thinking about testability. Don't rush to write code. Don't try to integrate all these mixing various different parts together and say, wow, look, it works. But step back and say, before I bring these together, how do I approach this from the point of view of testability? Because if I can't test it, it's really hard for me to evolve the design and look for regression later on. So approach this from the testability point of view. So we talked about what a fake is. A fake is just a service. Sometimes you use an in-memory database, for example. That's an example of a fake as well. So you could use a fake database, or you can use a fake service like the credit processing service I talked about, and you can design your application with these kinds of setup. If you're talking to a couple of different services or microservices within your own application, during testing time, you can have microservices that are fake, and in production, of course, you would talk to real services, and you can work with those very easily. So try to come up with these kinds of fakes first of all. But having said that, let's move on to talking about dealing with dependencies in other ways. So if you look at this particular example here, you want to be able to automate and test the class that's marked here as hard, but how do you automate and test it? Well, for this, you would have to fake away or mock away the class on the top and the class on the bottom. So you want to be able to really replace these two real dependencies with something that can stand in its place. And that is exactly what mock objects really are for. So what is a mock object? A mock object is an object that stands in for a real object. Let's say you want to make a movie with your favorite actor. Maybe I want to make a movie with, let's say Harrison Ford. Well, Harrison Ford is very expensive, obviously, and if I'm going to have a movie with him, I don't want to ask him to come in the morning at 8 o'clock for me to set the stage and set everything to his height and weight and so on. So what do? Well, I drive around, I find a guy on the corner of the street who is about the same height and weight as Harrison Ford, and I say, hey, you look like Mr. Ford. And of course, the guy is already delighted, and you tell him you'll buy a Coke and a burger, and he gets to see Ford today, and you can bring him over, and he is ready to help you out. Now, of course, this person is not as good as Harrison Ford, because if he were, you might as well make the movie with this guy other than having Harrison Ford over. So the point really is a mock object is an object that stands in for a real object. Now, obviously, this mock object, you want to quickly make use of the mock object, make the mock object, useful, and you want to get, this person going. The point is you don't want to grow this mock object and make it expensive and hard to maintain. So keep that in mind. We'll come back to the details when we look at some examples along the way. So a mock object is an object that stands in for a real object. Well, then the question is there a difference between fake and stub and mock and spy and all of those things? Well, these are all different terms we often hear, but let's understand what these terms mean. I also recommend you take a look at a blog entry that Martin Fowler wrote on this topic. Easiest way to get that blog entry is just copy and paste this stub versus mock in Google, And about the first link you would see is Martin Fowler's article where he talks about the differences between these things. So go ahead and Google search and read about it. Well, a fake is simply a service that takes a shortcut and may provide you a fake response and may not be used in real production. Like the credit processing system I talked about, they provide a fake service for test keys versus a production service goes to the real service. That's a way to fake away. Now, using fakes is relatively simple. It makes our lives a lot easier, but you are working with a real service which has been internally faked out. And that is definitely a good solution in a lot of situations, but it is not something that helps us in every single case. For example, if I were to use a fake service, while it's very convenient for my service to be looking for credit processing, and I use that quite a bit, but there are some disadvantages of this fake service. Now, I mentioned there is a test key I can send to this fake, and then it would route to a fake service rather than production, which is great. But unfortunately, as I travel around the world, I often am in a very slow network connectivity. In those times, my integration tests, when they talk to the fake service, are relatively slow. My real service is on the cloud. It is not slow because it's got really high speed internet connection, but me as a lowly programmer sitting down and writing tests in various different airports and lounges, I don't get the luxury of fast internet connection all the time, and so my integration tests tend to become quite a bit slower. But even worse, as convenient as these fakes are, when I'm in an airplane, oftentimes as I am, and I don't have internet connection, I'm pretty much stuck with not running these integration tests because I can't talk to a fake service as much as I can talk to a production service. So fakes have these limitations. On the other hand, a stub versus mock, let's distinguish between the two of them. A stub, on the other hand, is an object that stands in for another object, but it simply returns really responses that you key in. So you cook up some responses and you say, whenever a request is made, simply return these cooked up responses. And that's what a stub really does. For example, you could do some plots. I'll share with you an example. I like to have some fun from time to time. So I was teaching a course for a particular client a couple of months ago, and I decided to pull a little bit of a prank. The person who organized the course was going to come to have lunch with the team on Thursday, the team of people that I was teaching the course for. So I went around and I got a really good idea suddenly, and I said to everybody in the class, I said, would you all please do me a favor? When this wonderful organizer comes along, tell the organizer this is the most terrible course you actually ever took and you're very disappointed. So the organizer comes for lunch and everybody puts their head low. In a very seriousness, they say, well, this is the most terrible course we took. We expected something very different. And so we were just having fun to see how this organizer responds. Well, actually, this turned out to be extremely funny, and it turned out to be a really wonderful experience that this organizer goes around and tells the story quite often now these days. But this is an example of just letting everybody to return a fake to response. Now, you basically go to everybody and say, when this question is asked, return this response. And that is exactly what a stub is. Well, in this example, the people really that did the work were the people in the class, but in automated testing, you would have a real class and you would create another class which is going to be the stub for it. Well, then what is the mock then? Well, the difference between a stub and a mock is a mock will tattletale while a stub simply returns this response. A mock will come to you at the end of the call and say, well, let me tell you what really happened. You said the call will be made 3 times, but I really found the call was made only twice. Did you know this? And so it keeps track of the specific interactions between the code being tested and the code you depend on, in this case, replaced by this mock. So in other words, a stub is useful for testing state of an object after an interaction. So you have a code under test, you connect a stub to it, and then you call the test on the code you are testing, and then you come back to the code you are testing and saying, hey, is your state what I expected you to be? Mock, on the other hand, is useful for behavior and interactions. You are not just interested in knowing that your object is in the proper state, but you are also interested in making sure your object has the right interaction with the object you depend on. So that interaction or the dialogue between the code you are testing and the dependent object is being tested using the mock. Now, almost invariably, I tend to use a stub more than I tend to use a mock, even though very loosely I tend to use the word mock in general. But if you use tools for automated testing with mock objects, some of these tools provide you stubs, some of them provide mock, and if they provide mock, at the very end you can call a verify to make sure the code you are calling actually interacted the way you expect it to interact. So these can be very useful and powerful ways to find out the series of interactions. There is one more thing we will also talk about later, is called a spy. A spy actually is an object that stands in for a real object, and in fact it lets you talk to the real object, except it takes away some of the methods of the real object. So rather than completely replacing an object you depend on, it simply proxies in front of an object you depend on, lets some calls pass through and block other calls and provide a fake response to you. So a spy can be very useful to talk to an object which is very complex, but you only want to really take a select set of methods and alter its behavior or the response and fake away those responses alone. So we talked about fake, stub, mock, and spies, but depending on what you're trying to do, you may pick and choose between whatever these things are. Again, refer to the article I mentioned about stub versus mock by Martin Fowler, and you can take a look at some of these differences in more detail. But how do we really use mock objects? Again, I'm using the word mock very liberally here. Stubs or mocks or spies, how do we normally end up using them? Well, we use a principle, a design principle called the dependency inversion principle for this purpose. So let's take a look at an example of what this dependency inversion principle is going to provide for us. So here is on the left side a piece of code I want to test. So this is the piece of code on the left, and the one on the right is the code that this code depends on. So as I'm starting to write test on the code on the left, even test first before the code exists, I know that when I'm writing this code, it's going to talk to this dependency. So what do I do? Well, here's what I'm going to do. First of all, rather than my code talking to this object that I depend on, instead, I'm going to introduce a level of indirection. What David West said, in computer science, we can solve almost any problem by introducing a level of indirection. Well, the indirection here is inversion of the dependency. Notice in this example, the concrete class being tested depends on the concrete class which we are depending on. Instead, we move that concrete class down and we introduce an interface. Now notice both the concrete class on the left and the class we depended on before in the bottom, they both depend on this interface. In other words, we decoupled this. Rather than the class being tested being tightly coupled to the class we depend on, we decoupled it. So the class now depends on interface, and the class we depended on before also depends on the interface. Now we can easily introduce a mock object in place, and now this mock object also implements the same interface. During automated testing, we can take an object of the mock, connect it to the object we are testing, and run the test cases. So now when the test request comes in, the class makes a request to the object it depends on, but it doesn't know it actually is talking to a mock. And the mock is going to return back a fake to response, a real response we have cooked up, and it's going to return that response. And what does this do? It does its work and returns the response back to you for your test to pass. In integration test, or in rather production setting, the code that we really wanted to depend on, we're going to connect it to the object. Now when you run your real code, it makes a request like you did before, but those requests go to the real object rather than going to the mock object. So we can easily test our code automated. And what are the benefits? The first benefit is the test can be fast. It no longer has to talk to this complex object it's dependent on. It can talk to a mock which is relatively fast. Second, the test becomes more predictable. We can set up the mock to tell the lies we want it to tell, to cook up results we want it to cook up, and as a result we get back the predictable results based on which we can run the test. I'll talk more about this in just a minute. So this gives us the benefit to do all of those wonderful things. But that poses one challenge, however. If you look at the class we depend on, a minute ago, our code was depending on that class on the right side. Now, for the sake of testing, we are saying, let's move that class down and connect it to this interface, which means we have to modify the code we depend on to do this. Well, if the code that's on the right side is in your political control, it's in your team, it's in your company, it's in your organization. Either you can change it yourself or you can convince the people involved to make that change. This approach is pretty good. You can certainly use that and then create the mock object. But unfortunately though, what if the code you depend on is not your code? It's not something you can influence the change. It's not something you can modify and make it inherit from this interface. What do you do then? Well, in that case, you could apply the adapter pattern. So you could move that class to the side, introduce an adapter. The adapter is what you write. It can inherit from the interface you decided to introduce, and then it can route the call to the dependent object. In this case, the dependent object doesn't have to change anyways, and you can go through the adapter. So an adapter pattern can be very useful when you don't have the ability to modify the class you depend on. So this shows us some of the techniques we could use. We're going to get into the details of this using code examples real soon. But before we continue to the code example, let's talk about when to use a mock and what are some of the reasons to use it. Well, the very first thing is mock. Again, remember I'm using the word mock liberally here to represent any of those four categories we talked about: fake, stub, mock, and spies. A mock is useful to simulate behavior of a code. So you can say, here is a piece of code and here is the right behavior for this piece of code. I want to mock that out. I want to fake that out, and I want to cook up a result, and I'm going to call my code in test. The code in test makes a call to this. It gives us that cooked up response, and that's the right behavior I expect. And my code is going to say, aha, you gave me the right result. I'm happy. I'm going to continue doing stuff. For example, I'm going to simulate a situation where a user, John Doe, has given me a valid credit card number. So I would fake away or mock away my credit processing. I would send a valid credit card number. Now, there is no concept of valid versus invalid during test case. So whatever credit card number I decide to use is considered valid. What does my mock do? My mock simply says, oh, you want me to pretend that this is a good credit card number? Okay. And it would just immediately return a response to you saying, credit card processing successful, no errors. Here's your fake transaction ID. And here is the amount charged. What does my code do? My code says, oh, expect the credit processor to do the right job. Oh, look, it gave me a no error. It gave me a success. It gave me a valid transaction ID. What am I going to do now? Well, I'm going to go create an entry in the journal for the successful transaction. I'm going to authorize whatever the user should get, the product they were charging for. I should okay it. Maybe send a request to my inventory system to say, go process this. And I could probably notify the user on the UI saying, hey, good news. Thanks for purchasing. Your order is on your way. And maybe send an email to the customer saying, we are processing the inventory, and to check back, and we will give them a tracking number later on. So think about how Amazon is doing all of this. When you go enter your credit card number and say, purchase this book or these books, what are the sequence of steps that happen? Now, clearly, you want to be able to test this, and that's what we are talking about, is that this is going to do the test with this mock, which is going to give you the right behavior. Well, a couple of years ago, there was a day when credit processing systems went down for about 30 minutes or so. But unfortunately, most of the services that depended on this took about hours to a couple of days to recover. Now, why is that? Because unfortunately, most of them did not test for ill behavior or when things actually fall apart. So you want to make sure your code does the right things when things do go wrong. Now, what could possibly go wrong? Well, there are several things that could possibly go wrong. What if the credit processing system is offline? What if your server is disconnected, partitioned from the network? What if the user enters a wrong credit card number? What if the user gives a credit card number which is invalid or expired or out of credit or wrong CSV number, wrong address, wrong name, whatever those errors are? You want to make sure you're testing for those different situations. And when the credit card processing engine gives you an error, what do you have to do? So you are simulating the situation by creating a mock object and saying, hey, mock object, do me a favor. I'm going to give you a credit card number and I want you to give me a result that says error. And give me a transaction code for error and tell me the reasons for error. Now you are testing your code to make sure that it notifies the user appropriately. Plays a sad music saying, sorry, we couldn't process your payment. Do not charge. Do not really make things available for the user because they didn't make the payment. And do not really go around making other transactional commits. And you want to make sure that your code is behaving properly when the service you depend on ends up failing. So not only do you want to simulate behavior, you want to simulate various ill behavior and make sure your code is doing the right things when what it depends on works, and it also is doing the correct set of things when the code it depends on ends up failing as well. And this gives us enormous amount of confidence. It gives us peace of mind. It tells us that things are working the way they are supposed to work. And when you evolve the code and make changes, when you run all these automated tests, it gives you a feeling that everything is still working. It also helps you to make sure when things do begin to fall apart, you can quickly run your tests. And if your tests are failing, you know the problem is in your code because you're not talking to the real service, you're talking to a mocked service. So if something is failing, you are at fault in your code. But if your automated tests are passing, but integration is failing, that means there's nothing wrong in your code. There's something wrong in the code you depend on, potentially, or the interaction has been modified. Well, something could be wrong in the code you depend on. Maybe the service was modified, so they no longer send the response the way they did. Maybe they changed their error code. It's time for you to come back and evolve and modify your test cases and evolve through because the service you depend on is no longer behaving the way it was behaving before. They changed the contract on you, which means you got to change the code to meet with that change. That quick feedback loop immediately tells you the problem is not in your code, the problem is in the other code, and because they changed, there are things you need to change, or sometimes you report back to them saying, hey guys, this is the contract, that's what this says, you no longer are sending this code, and oftentimes they're like, oh, our fault, and they can go back and change it. Or if it's not the problem with any change on their service, maybe there's something wrong in the protocol, in the expectation you have in things that are coming back, and maybe certain API was modified, or maybe it is sending a different set of headers. Whatever the case may be, you are able to deal with that. In other words, it helps you to isolate the problem very quickly. Remember, it always takes more time to find a problem than fix it. This can quickly give you a clue whether the problem is in your code, if your automated tests fail, or the code is in the dependency and interactions with the dependency if the automated test passes but the integration test is failing. So this can be a very powerful way for us to get to know very quickly where things went wrong. So we talked about how to approach testing with dependency. We could use fake, mock, stub, or spies. But all this doesn't make any sense if we don't look at code examples. So in the part 2 and part 3, we will start looking at some code examples and dig deeper into how we can effectively apply the concept of testing with dependencies using stubs or mocks, whatever we want to use, but we will take a look at how to do that. So let's get to the code example in the next part.